Now we've been able to identify how to find the slope of the tangent line, but we have to take it one step further and actually derive the equation then of the tangent line. You first have to find the slope, but then you can actually go ahead and construct then the tangent line from that. Now what we've been seeing in the past is actually how to go ahead and find the secant slopes. And what we were doing was pretty much just subtracting the y value of some other point minus the y value when we threw in our target from our target y value over some other x, again from that point, that other point, minus our target x. In this case we defined it as a. Now it was our hope then that eventually this slope came out to be our tangent slope, and we did that through our limits. So eventually, applying our limit, we ended up with this thing, this slope, coming out to be our tangent slope. And again, that was through our limit process. Now, if we want to go ahead and construct the equation of a line, it's actually not that hard. In fact, we've kind of actually already seen this before back in algebra. If we were to, for example, go ahead and multiply both sides by this bottom x minus a to kind of clear that fraction, well, on the left, the x minus a cancels out with this x minus a, leaving us with just the y minus f of a is equal to the slope of our tangent line times x minus our target x value, a. And believe it or not, maybe you can recognize it. If not, that's okay. But hopefully you can. This is actually point slope. So it goes back even to algebra, where we see point slope being used. Even calculus is actually being derived from it. And now if we wanted to actually construct then the line from this, well, we know that from point slope that we just added this piece over there, thus giving us then that y-intercept. So we end up then with y is equal to the slope of our tangent times x minus our target x plus f of a. And this slope and this target point kind of work together, and then you'd add this y-intercept. But more or less, that's actually pretty much then how you actually construct the equation of your line. Now looking at example 2, let's go ahead and use that information. We're asked to find the equation of the tangent line from our warm-up. Well, we know that our slope from that warm-up came out to be 2. So from example 2 in the warm-up, we said that our tangent slope came out to be 2. We also know our target point, and that was 1, 2. So we can then go ahead and throw those values in there, where we have y minus, just to kind of actually prove this thing in action, we have y minus our target y value. Well, here he is, 2. All over x minus our target x value. A was 1. And again, this is equal to our tangent slope. In this case, here is our tangent slope, 2. Well, now we can go ahead and pretty much follow the process that we just did for our definition. Multiply both sides by this x minus 1 and clear that fraction. On the left side, they end up canceling out with one another, that x minus 1, leaving us then with just that y minus 2. On the right side, we see that we have that tangent slope times that x minus that target value happening right here. So then we end up with 2 times x minus 1. Just so you guys can actually see the final form matching with our definition, again, we're going to go ahead and add 2 to both sides. Typically, when we did our point slope back in algebra, though, we would distribute this first. So then when we end up with y is equal to 2 times x minus 1 plus 2. And there you can see it is in fact matching our definition. We have that tangent slope times x minus our target x plus our target y value. Now let's go ahead though and clean this up a little bit. Just distributing this, we end up with y is equal to 2x minus 2 plus 2. Well, these 2's end up canceling out with one another because one's negative and one's positive. So it looks like our equation of our line comes out to be y is equal to 2x. What I've gone ahead and done is actually graph that function y is equal to x squared plus 1. Now, again, we've already found our line, our equation, that is tangent to this particular function at this particular point, 1, 2. So let's actually go ahead then and see what's going on graphically. If we go ahead and graph our line y equals 2x, there it is. And we can even see that at 1, 2, it is in fact tangent there. It's only grazing it once, specifically at 1, 2. So that just proves then that this is in fact our tangent line. Again, that is example 2 continued from our 2.1 set of notes.